Hello student, let's continue with the trigonometrical identities. The next question, secant theta minus 1 by sec theta plus 1 is cot theta minus cosecant theta whole square. Left hand side. Here we got sec theta, here cot theta, cosecant theta. So convert them into cos theta. This can be written as 1 by cos theta minus 1 whole divided by 1 by cos theta plus 1, which is equal to 1 minus cos theta by cos theta. Taking cos theta as the LCM, 1 minus cos theta. Again, taking cos theta as the LCM, I get here 1 plus cos theta. This gets cancelled out, so I get 1 minus cos theta by 1 plus cos theta. Now divide and multiply with 1 minus cos theta. So what we get here is 1 minus cos theta whole square by 1 minus cos square theta, which is equals to 1 minus cos theta whole square by sine square theta. Is it clear? Because 1 minus cos square theta is sine square theta from the trigonometrical identity formulas. Now RHS, right hand side, this is equals to cot theta minus cosecant theta whole square. Cot theta can be written as cos theta by sine theta minus 1 by sine theta whole square. This can be written as sine theta by cos theta minus 1 whole square. This can be written as cos theta minus 1 whole square by sine square theta. Here in the left hand side we have seen the denominator sine square theta. Here it is also denominator is sine square theta. But in the numerator I find it is 1 minus cos theta whole square. But here we find it is as cos theta minus 1 whole square. Now we know that 4 minus 2 whole square and rather 4 minus 1 whole square and 1 minus 4 whole square. You see 4 minus 1 is 3. 3 whole square is 9. Now 1 minus 4 minus 3 and minus 3 whole square is also 9. So when it comes to square, so a minus b or b minus a whole square remains the same. When it comes to square, a minus b or b minus a remains the same. Or we can write this as, like, suppose if I take minus sign common here, I get here 1 minus cos theta whole square by sine square theta. Can I take minus sign common here and I get 1 minus cos theta? Now when I square this negative sign becomes positive sign and I get 1 minus cos theta whole square by sine square theta, which is equals to your LHS. Therefore right hand side is equals to your LHS. Is it clear? Is this step clear? 4 minus 1 whole square, 1 minus 4 whole square is the same thing, because for square. The next question, tan theta plus sine theta by tan theta minus sine theta is sec theta plus 1 by sec theta minus 1. LHS, left hand side. Tan theta, change it to sine theta cos theta. Sine theta by cos theta plus sine theta whole divided by sine theta by cos theta minus sine theta. Then take LCM as cos theta here. What I get is sine theta plus sine theta cos theta whole divided by, again if I take here cos theta, then I get here is sine theta minus sine theta cos theta. This cos theta, this cos theta gets cancelled out. From here I take sine theta as common. I get 1 plus cos theta. Again from here I take sine theta as common. I get 1 minus cos theta. This gets cancelled out. So I get 1 plus cos theta by 1 minus cos theta. The LHS. Now what about RHS? Sec theta plus 1 by sec theta minus 1. Convert sec theta to cos theta. 1 by cos theta plus 1 by 1 by cos theta minus 1. Then cos theta 1 plus cos theta by again cos theta 1 minus cos theta. It gets cancelled out. So I get 1 plus cos theta by 1 minus cos theta. LHS is equals to RHS. LHS is equals to RHS. Proved. Next question. Eliminate theta. It is given that x equals to a secant theta and y is equals to b tan theta. From here we have to eliminate theta. That means we will have to find a relation between x and y. There will be no theta. So see, this is a different type of question. Understand how we do it. From here, x equals to a secant theta. We know that secant theta is equals to x by a. Yes, secant theta will be x by a. From here, y is equals to b tan theta, and tan theta is y by b. Now we have to eliminate theta. That means there will be no theta. How can we eliminate? We know that 1 plus tan square theta is equals to secant square theta. Yes, from the trigonometrical identity formulas. Now put up the values here. Like 1 plus tan theta is y by b. So tan square theta will be y square by b square is equals to secant square theta. Secant theta is x by a. So secant square theta will be x square by a square. Or we can write this as 1, or we can write this as x square by a square minus y square by b square is equals to 1. This is your answer. This is the way. See, there is no theta in this relation. Clear? Another question for how to eliminate theta. X is equals to h plus a cos theta. Y is equals to k plus b sin theta. Here I am saying sin theta and cos theta. So what is the relation? We know that sin square theta plus cos square theta is 1. So we will try to find out what is, we know x equals to h plus a cos theta. Therefore cos theta is equals to x minus h by a, and from here y is equals to k plus b sin theta, or sin theta is equals to y minus k by b, and we know the formula sin square theta plus cos square theta is 1. Therefore put up what is sin theta. This will be y minus k whole square by b square sin square theta, plus what is cos theta, x minus h whole square by a square is equal to 1. This is your answer. Clear? X cos theta is x minus h by a. Therefore cos square theta will be x minus h whole square by a square. Similarly sin theta is y minus k by b. Therefore sin square theta will be y minus k whole square by b square. The next question is same. It is given secant theta plus tan theta is equals to m. Secant theta minus tan theta is equal to n. So the question can be eliminate theta, or the question may be prove that mn is equals to 1. it's all the same thing. They can either ask you eliminate theta or ask mn is equals to 1. So how do we do? We know that secant theta plus tan theta is m, secant theta minus tan theta is equals to n. Now add these two, what we get? 2 secant theta is equals to m plus n, and secant theta is equals to m plus n by 2. Now again, secant theta plus tan theta is equals to m, secant theta minus tan theta is equals to n. Now subtract. So what you get? What you get? We get this 2 tan theta is equals to m minus n, or tan theta is equals to m minus n by 2. Now we know that 1 plus tan square theta is equals to secant square theta. Remember that identical formula? 1 plus tan square theta is secant square theta. Now put up the values. What I get? Or tan square theta, or we can write as tan square theta minus secant square theta is equals to 1. Secant square theta minus tan square theta is equals to 1. Secant square theta minus tan square theta is 1. Now what is secant square theta? M plus n by 2 whole square, minus what is tan square theta? M minus n by 2 whole square is equals to 1. So this will become m square plus n square plus 2mn by 4. Opening this a plus b whole square, m square plus n square plus 2mn, and this 4 here, minus again m square plus n square minus 2mn by 4 is equals to 1. Now LCM here will be 4. I get here m square plus n square plus 2mn minus m square minus n square plus 2mn is equals to 1. M square n square gets cancelled. I get 4mn. So coming up here, I get 4mn by 4 is equals to 1. Therefore mn is equals to 1. This is your answer. Either if they ask you to find eliminate theta, the answer is this, or prove mn is equals to 1, it is proved. This is another type of question where it is given that if 2 sine a minus 1 is equals to 0, show that sine 3a is equals to 3 sine a minus 4 sine cube a. How do we do this? First, from here, find the value of a. Find the value of a. We know that it is 2 sine a minus 1 equals to 0. Therefore, sine a is equals to half. And where is sine half? Sine is half in sine 30. Sine 30 is half. Therefore, a is equals to 30 degree. Clear? Now put up the values here. Here it is given that sine 3a is equals to 3 sine a minus 4 sine cube a. Now sine 3a. 3a means 3 into 30. 3 into 30 is equals to 3 sine 30 minus 4 into sine cube 30. So this becomes sine 90 is equals to 3 into sine 30 is half minus 4 into sine cube 30. Sine 30 is 1 by 2. 1 by 2 whole cube. Now what is sine 90? 1. Here it is 3 by 2 minus 4 into 1 by 8. This becomes 1 by 2. So this becomes 3 minus 1 by 2, which is equals to 2 by 2 is equals to 1. Therefore, LHS is equals to RHS. Proved. Clear? Next question. We have to find theta. It is given that 4 cos square theta minus 3 is 0. And it is also said that theta lies in the first quadrant. That means theta will always be positive. Remember. Now it is given that 4 cos square theta is equal to 3. If I take 3 that side, or cos square theta is 3 by 4. Therefore, cos theta is equals to plus minus root 3 by 2, taking the square root. Now, as I said, theta lies in the first quadrant. That means theta will always be positive. Therefore, cos theta will be root 3 by 2, as theta lies in first quadrant. Clear? Now, when is cos theta root 3 by 2? At what value of cos theta is root 3 by 2? It is 30 degree. Cos 30 degree. Therefore, theta is equals to 30 degree. Theta as it lies between 0 to 90. The next question. It is given sine square theta minus half sine theta is equals to 0. We have to find the value of theta. Taking the LCM, we get 2 sine square theta minus sine theta equals to 0, or 2 sine square theta minus sine theta equals to 0. Taking 2 that side, then taking out sine theta as common from here, I get 2 sine theta minus 1 equals to 0. If I take sine theta from here, therefore either sine theta is equals to 0 or 2 sine theta minus 1 equals to 0. If sine theta equals to 0, which is equals to sine 0, therefore theta is equals to 0 degree. Or from here, if I say sine theta is equals to half, which is equals to sine 30 degree, therefore theta is equals to 30 degree. Now see, if the question says theta lies between 0 and 90, then my answers will be both. But if it says, then my answers will be theta is equals to 0 or theta is equals to 30 degree. But if they say that 0 to 90, here see the symbols here, theta is greater than 0, less than 90, then your answer will be theta is equals to 30 degree. So just do not write the answer, see what is given. If it is given that theta is equal to or greater than, then you have both the answers. But if theta is just greater than 0, that means 0 cannot be the answer. The answer will be this. So please keep these also in mind when you answer the questions. The next question, we have to find theta. Given 2 cos square theta plus sine theta minus 2 is equals to 0, and theta is greater than 0 but less than 90. Clear? So what we have got to do, we have to change cos square theta in terms of sine square theta. So 2 cos square theta can be written as 1 minus sine square theta plus sine theta minus 2 equals to 0. Open up the bracket, we get 2 minus 2 sine square theta plus sine theta minus 2 equals to 0. This plus 2, this minus 2 gets cancelled. So if I get here, take sine theta as common, I get minus 2 sine theta plus 1 equals to 0. Therefore, either sine theta equals to 0 or 1 minus 2 sine theta equals to 0. 1 minus 2 sine theta equals to 0. Now sine theta equals to 0 is sine 0. Therefore theta is equals to 0, or sine theta is equals to 1 by 2. Yes, which is equals to sine 30 degree. Therefore theta is equals to 30 degree. Again, what is the condition? Theta is greater than 0 and less than 90. So theta is greater than 0. This answer will not be correct because here theta is 0. Here theta is 0. As theta is greater than 0, therefore theta is equals to 0 is wrong. Therefore we have the answer as theta is equals to 30 degree. This is your answer. There is another type of question. It comes like this. Given if A is an acute angle and secant A is 17 by 8, then find all trigonometrical ratios using trigonometric identities. Now what do you mean by trigonometric ratios? Trigonometric ratios are sine theta, cos theta, tan theta, cot theta, cosec theta, secant theta. These are known as the trigonometrical ratios. So trigonometric ratios. What are trigonometric ratios? Sine theta, cos theta, cosec theta, sec theta, tan theta, cot theta. These are the trigonometric ratios. Now we have to find the values of these ratios where it is given that secant A is 17 by 18. So it is given secant A is 17 by 18. It is already given here. I found out here. Next, I know what is cos A. Cos A is equals to 1 by secant A, which is equals to 1 by 17 by 8. 17 by 8, which is equals to 8 by 17. I know what is cos A there? 8 by 17. Therefore, cos theta is 8 by 17. Yes. Now we have to find the values of other of these using trigonometric identities. Not in 9 what we have learned as taking like this, then find out by Pythagoras theorem, finding out the various values and putting it up. No, we have to use trigonometrical identities. Now I know secant, we know that 1 plus tan square theta is secant square theta. We know tan square theta is secant square theta minus 1. Therefore, tan square theta is equals to what is secant square theta? 17 square by 8 square minus 1. 17 square by 8 square minus 1. What is 17 square? Not required. I can do it by this way. Yes. Now 17 plus 8 into 17 minus 8. If you do not know the formulas, squares of 17, or it is 8 square. So what I get? 25 into 9 by 8 into 8, or 8 square. Therefore, tan theta is equals to root 25 into 9 by 8 square, which is equals to 5 into 3. 5 into 3 by 8, which is equals to 15 by 8. Therefore, tan theta can be written as 15 by 8. So what will be cot theta? Opposite of tan theta? 8 by 15. Now it is left sine theta and cosec theta. We know sine square theta plus cos square theta is 1. Therefore, sine square theta is equals to 1 minus cos square theta, which is 1 minus 8 by 8 square by 17 square, which is equals to 17 square minus 8 square by 17 square. We know if you know the tables, fine. If you do not know the tables, then we will do it as 7 plus 8 into 17 minus 8 by 17 square, which is equals to 25 into 9, which is equals to by 17 square. This is equals to sine square theta. Therefore, sine theta will be root of 25 into 9 by 17 square, which is equals to 5 into 3 by 17, which is equals to 15 by 17. Therefore, sine theta is 15 by 17. Sine theta is 15 by 17. And what is cosec theta? 1 by sine theta. That means it becomes 17 by 15. So this is the way we find the trigonometrical ratios when one value is given using trigonometrical identities. Clear? If you have any doubts, you can please comment on our comment box. I will reply you back. Thank you.